Howdy. So we have yet another old Ford EEC unit here that we got to repair. And this one, they sent me some information here. So basically, they have no signal on pin 12. And they sent me, I guess this is, I forgot the name of this site, but it's where technicians can, say what the problem was and what they did to fix it. And they've highlighted here if pin 12 wire is shorted to ground and the code keeps coming back that the PCM is faulty, to replace the PCM. So I'm assuming that they did this uh, test procedure here, and this is the result they got. And they have this one fix here from a Mr. Hoffman, and he said he cut the wire pin 12, and then he said 12 volt was from the computer and 12 volt on the wire. There was no ground, and the PCM still set the code, so they replaced it, and it shift normal. So this has to do with the transmission not shifting here. So let's see. This is a self-test to check for code 633. It indicates that the PCM thinks the vehicle is in 4x4. But anyway, let's take a look here. So I don't remember pin 12. I don't remember digging through what that is. So we're going to use our meter here and just kind of feel around. Since it said it senses if the car is in 4x4 or 2x4, I guess it maybe is just like a signal that's going to go straight to the processor. I mean, it might go through some passives and whatnot, some conditioning, and then just go to the processor. So it's possible the processor is going to be bad, which I hope not, but typically from what that paper said, it seems like it's looking for either a high or a low signal to tell if, the 4x4 is active or not. And if that signal is missing, that means it's either open in the wiring, or could be open in somewhere in the circuit between the connector and the processor, or it could just be the input or output for the controller here. The processor is just shot. It's just stuck either high or stuck low, which happens quite a bit with these older processors. But let's see. Let's go through and see what we can find out. Hopefully, it's something we can fix. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and this is pin 12 right here. So I'm just going to put that little alligator clip. I am going to untangle my wires just a little bit here. I'm going to clip this guy here to this end, and we're going to probe around with this side. And I guess I can turn on my equipment view for you. All right, there we go. So let's put this on continuity mode, and let's just kind of poke around until we see what we're doing here. Okay, so this is pin 12, and it's nice we can follow this trace here. It goes to this capacitor, and it also goes to this one of these two resistors. It goes to this resistor right here, and this resistor, you know what, let me put my scope as well so you guys can see. That resistor looks like it's on a like a pull. It looks like some kind of pull-up resistor, because I can see like a maybe 5 volt, or maybe it's even 12 volt rail that it's connected to. See if I can get this where you guys can see both views. I know my setup is not quite perfect, but it's a little bit better than nothing. So let's put this here since that's kind of getting blocked. All right, so here is the resistor I was talking about. Okay, so we can see we have continuity there. And if you look here, this is what I was saying. It looks kind of like some kind of pull-up because that's a really fat line there. I'm not 100% sure, but I would think. Okay, so let's go back over here because I noticed this trace kept going. So this is the trace. You see it come in here, it come to this capacitor. Our capacitor does not appear to be shorted. Our resistor doesn't appear to be shorted, so let's follow it. Follow it. Which one was it? This one. Okay, and it comes to this resistor here. This 47K, I guess. No, 4.7K. Then it comes here. And it comes here. So this looks like a test point. So this is going to be our through hole. And if we look at it, we see it's 2 holes and it's right next to whatever this big thing is on the other side. So let's unhook that. Let's see if we can't hold this some kind of way. So this part might not be under the microscope for a second. So I want to try to find, okay, this is the big diode, or either this one. So I just want to kind of feel around. Come back to this side because I fell off. I want to just make sure that probe is on that hole and it keeps slipping. But I do see what I think is the through hole on this side. I just gotta verify. Yeah, there it is. Okay, so I got this one. Okay, so I got my probe on it there. That is it. And if we follow this trace, it comes through here and it comes right over to here. It should be this one. And it should be this one, but we don't have anything. That's kind of weird. When I was just now looking, I noticed a little bit of weird green stuff here. You know what? I think we have an open trace. You see this green stuff? Is the microscope picking? Yeah, it's picking it up. You see this black? I think maybe under here. I mean, nothing looks bad, and there's no capacitor that was leaking. These are replacement capacitors somebody put in here. It doesn't look bad, but I think, oh, wait a minute. That's a different trace. This trace comes over here. So this trace actually goes up in here to right there, which is this one. It's got to be one of these. So 1, 2, 3, because there's only a few of them over there. Let's see. It's the bottom one. So the 2 and then the 3. Okay, so let's check here. So it should be this one. And this was our other one. But it's still open. I think we still got a shot, guys. I think we still have something going on here under this pad, which is going to be pretty lucky for us if that's all it is. So let's move this big diode out of the way. Which one was it? So this one. I don't know if I have to completely take it out. Sometimes for these things I just lift up one side, but this one's kind of big. I think we better just do the whole thing here. Let me see if I got a solder sucker here somewhere. All right. I feel like I was lifting the wrong one out. I think I was. I think I desoldered the wrong one there. Can't tell. All right, so now let's investigate and see if we have a. We do. We have an open trace right there. Nice. I think uh, I think we found the issue with this one, and it's not the main processor, which I'm very happy about. I was a little bit worried about this one, to tell you the truth. I'm gonna get this stuff out of the way. I just wanted to make sure there wasn't, capacitor juice stuck under there. Usually when I open these, I'm used to seeing really bad capacitors, but this one has brown caps, so I can tell that they're already been replaced. And I don't see any damage, so somebody actually done these early, but it must not have been early enough for this one. Because here is our open trace, and that is directly related to our number 12 pin. And I do want to keep tracing this to see where this was to go. I assume it goes straight to the processor now because it went through the 4.7K resistor, kind of conditioning the signal there, protecting the processor. Let's see, it was this one, so if we follow this trace, comes all the way down to here. That comes to over here. It looks like it's coming through here. It's probably, it's not one of those, so it's got to keep coming through here. Probably one of these two. Man, I don't know what's going on with this thing. It looks like it comes all the way through here. Must be one of these ones that come up through the middle of these pins here, and then go straight to the processor. I mean, because that's what it's got. It's got to do that. That's just, that's what that is. So, all right, let's get this thing fixed and get it out of here. Okay, so I'm going to clean this area up just a little bit. And we're just going to put a little tiny jumper across there and call it a day. Okay, I want to cut this little end off too. I'm just going to touch this up a little bit. Touch this side up a little bit. And that is it. I'm going to clean that up and put a little bit of conformal coating over it. We gotta put that big diode back too. I probably should clean that hole out before I do this, but it'll just be easy there. Is it getting in the hole? Yeah, it's getting all that close. Alright, so we're gonna have to flip it over and get it from the other side too. This board, it's pretty thick board. Alright, so here is our diode back. Let's put him back here. I'm gonna put some IPA on there. Hopefully to neutralize whatever that green stuff was, that oxidation there. Must have got slippery. Can't hold on to it for some reason. Okay. Got that one in, got that one in. Just push it in a little bit. That's good. And we're just gonna hit this guy like that. I want to pick this side up a little bit. Since I took that little pad off, I want to just kind of, I think that was just to keep the board from cooking. Because I know this big diode here is going to get hot. So I guess there's some kind of like little heat pad there for it. So I'm just going to lift it up off the board there so it has good airflow. I think that should be good enough. Alright, let me check this other side. Because I do have it lifted up quite a bit, but I think it will be okay. And it looks pretty good. Just going to heat up a little bit more over here with this bigger iron. I think that's good enough. It's not moving. Okay, I'm going to straighten that capacitor back up. And now that it's all done, I'm going to put just another little brush of this conformal coating on there. Let me clean up a little bit of that flux too. No clean flux, but still not a bad idea to clean it up. Take that out of there. All right. Now let's put some more of this stuff down. And we're going to put it under here too to maybe help, since I took that pad away. Just in case it tries to overheat, which I don't think think it's really needed. But well, I think that's about all I'm going to do with this one. I'm pretty sure that is going to fix the issue, considering that this test procedure is pretty much saying that the issue is either an open circuit or a blown I/O. I'm 99.9% sure that's your problem and it's fixed. I got a lot to do, so I'm going to end this video here and move on to the next project.